enter the room measurements, and you're done. Well, not quite. Automation leaves less room for mistakes, and you get stuff done faster. While searching for ways to improve my workflows and construction calculators, I came across a ceiling estimate tutorial by Rawhouse PH. It was explained so vividly that I was inspired to make an automated version of it. Go check his channel out, it is awesome. Before anything else, I made an intro video for this series explaining what the colors mean and how the system works. Please do check it out if you're new to the estimate series. First, we start with the ceiling dimensions. We'll be using 2 input cells, which means we're assuming that the ceiling is a rectangle, as most rooms are. Make an output cell for the area and perimeter. I also made output cells for imperial units because you never know. Begin by identifying the ceiling grid. The carrying channels run parallel to the longer length. These channels carry the metal furring on which the ceiling boards are attached. Metal furrings run along the shorter length. Identify the spacing for each. Let's call each run of the carrying channel and metal furring a section. For the sections of the carrying channel, divide the shorter length by the spacing, then subtract 1. If you don't subtract 1, you'll get the spaces between them, not the sections. For a 10 by 6 room, you need a total of 50 meters of carrying channels because you have 5 runs measuring 10 meters each. Divide the total required length by the available commercial length, and that gives you the exact number of channels you'll be consuming. But what about extras? What if we're short one piece? We'll talk about allowances in a bit. Also, money. For the metal furring, divide the longer length by the spacing, -1. Spacing for the metal furring is usually 0.6 meters or 2 feet, which conveniently aligns with the board dimensions. For the total length required, 6 meters of metal furring are repeated 16 times, which gives you 96 meters. Divide by the commercial length, you get the exact quantity you need. Now, for the threaded rods on which the carrying channels are attached. You need to know the spacing and how far your ceiling drops from the mounting surface. These input cells assume a uniform spacing and hang. Compute how many rods you need for each run on a single carrying channel. Then, multiply by the number of sections. Our ceiling hangs 0.8 from the slab with 45 mounting points. We need a total of 36 meters. Divide by the commercial length, you need exactly 12 pieces. For the J-clips and expansion bolts, you need 1 for each drop, so there's really not much to compute. Now, for every intersection of the grid points, you need W-clips and blind rivets. For W-clips, some people use 2 each, some use 1. It is a matter of preference. To solve for the number of intersections, multiply the sections of carrying channels by the sections of metal furrings. After that, the quantity of W-clips and blind rivets at each grid point multiplied by the number of intersections gives you how many you need in total. Again, exact value. No allowances yet. For the perimeter measurements, the wall angle is simply the perimeter divided by the commercial length. For the concrete nails at every 0.3 meters of that same perimeter, you need roughly 107 pieces. For the finishing materials, you usually need the following. Dividing the ceiling area by the area of one board, you get the exact quantity. Each board needs more or less 36 pieces of black screw. Then, to hide the seams, you need some mesh tape or paper tape, depending on the specifications. Assuming there's roughly 75 meters in a single roll of tape, and you need 2 layers of it for every seam, take a deep breath, this formula is long. Assuming the boards are aligned the longer side, divide the longer side by one board's length, which is 2.44 meters or 8 feet. Add 1 to include the final section in your formula. Multiply it by the shorter side. Then, do it the other way this time. Divide the shorter side by the board width, which is 1.22 meters or 4 feet. add 1, multiply by the longer side. Now you have the total length of seams. Multiply by 2 layers of tape, you need around 192 meters of tape. When divided by the commercial length of 75 meters is around 3 pieces. Next is covering the seams with putty. To cover the 96 meters of seams with one coat applied at a width of 200 millimeters, you would consume around 19.2 square meters of putty. Assuming that a gallon covers 20 square meters, you'll need around 2 gallons. For the paint, have the sealing area divided by the coverage of 1 gallon of paint, then multiply by how many coats. This lets you know how many gallons of paint you'll need. As a contingency, I added the input cells for allowance. The default input is by piece. However, you can use the total required as a reference for a percentage-based allowance. Add them to get the total. Each item has a unit price. Multiplied by the total quantity, you get the total cost. I added the partial total for each portion for a bird's eye view of the estimates. The sum of them gives the total cost of the materials. Now, the labor cost. This is a touchy subject that considers how many people will be working and for how long. For brevity, I simply use the percentage of the material cost. Adding them together gives you the total cost. For a little razzle-dazzle, I included a per square meter cost, which is just the total cost divided by the area. A few final notes. Switching the entries for the longer and shorter sides changes the prices and quantities, so be careful with that. Second, this is only one of many sealing systems. If your finished materials are different, say spandrels rather than boards, you're gonna need another set of cells and formulas. L-shaped and U-shaped plans, even with the same area, would still require different computations. Perimeter is different, the grid is different, carrying channels, metal fairings, everything is different. Hope you enjoyed this page of